All right, we're going to do 7-3, but the key to 7-3, and you should like this, I hope, is that we're going to be solving a lot of this using a calculator. So most of it, except the ones that don't have real solutions, you're really not going to have to show a lot of work because you're going to do it in the calculator. Now you have to remember a couple things in the calculator. And you see it just asks for a sketch. It doesn't ask for a table of points, but if there is one, you can go to table like the videos in 7-1 showed and find it. If the roots are imaginary, that means if you have a negative under your radical, I want you to leave it in simplify under the radical. Don't give me a decimal answer. Okay, so that's a couple things to remember. In order to enter it in the calculator, you have to make it y equals, which means you've got to get everything on the left side. So we're going to take this equation and we're going to subtract 5 from both sides. And so you're going to work with 2x squared plus 3x minus 5 equals 0. Well, instead of equals 0, you're going to put it in the y equals, so it's going to be really equals y. And where y is 0 is your answers. That's why when you find the roots or you find the things on a graph, the roots, solutions, answers, whatever, those are all kind of interchangeable terms that that's what's going to solve your quadratic equation. So you're going to enter y equals 2x squared plus 3x minus 5, and you're going to put this in the calculator. Then you're going to hit graph, and you're going to sketch. If it crosses, if your discriminant is positive or 0, and if I'm going to remind you that the discriminant, and this is a way you can check real quickly, is what's under the radical. Discriminant. That's this part under the radical, which is b squared minus 4ac. And in our case, that's going to be 9. B squared is 3 squared. 9 minus 4 times 2 times negative 5, which is the square root of 9 plus 40, or 49. So our discriminant is positive. The part that's under the radical is positive. That means there's two solutions, two roots. This graph should cross the x-axis in two places. And so when you graph it and you look, you're going to see that somewhere this graph sort of sketches in here something like this. And just put it in the calculator to get that. That's not magic. I'm not making it up. You're going to get that from the calculator and sort of sketch it onto your graph. Then you're going to go in your calculator and you're going to find your zeros. Okay, so you find your zeros, and you've learned how to do that in 7-1. So once you find your zeros, that's your solution. Since it had a real solution, because the discriminant was positive, you're going to be able to do it in your calculator. So you go in and you find your answers, and they are negative 2.5 and 1. And those are actually points. The points are actually negative 2.5, 0 if you looked at them in the table, and 1, 0. Okay, don't put the solution to negative 251 in parentheses, because then to me that looks like you're trying to say that's a point. It's not a point, it's two different points. Okay, so now let's go on here. That's your first one. That's all you have to do. And let's go to our second problem that we've got listed. And again, to enter it in a calculator, you're going to have to move everything over. So you're going to subtract 3x and add 7 to both sides. So all this on the right is now equal to 0. So you're going to work with y equals 3x squared minus 3x plus 7 and that's equal to 0. So again, my answers are where the equation is going to cross the x-axis. Now our problem is when you graph this thing, and you may have to zoom out, change your window a little bit, you're going to see that this graph's up in here somewhere. So what that means is that there are no real solutions. Okay? So we're going to have to use quadratic formula and work this out. This answer is going to have an I. It's going to have a complex. It's going to have a complex root. Okay? It's going to have a complex root. So what we do then, this 3a is 3, b is negative 3, and c is 7. Okay, so we're going to use our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Alright, so negative b is going to be negative 3 or positive 3 plus or minus square root of 9, 3 squared, minus 4 times 3 times 7, all over 2 times 3. Okay, so let's simplify that down. X equals 3 plus or minus the square root of 9 minus 21 times 4 is 84 over 6. Now, let's look at what that discriminant does. Again, the discriminant is the part that's under the radical. So we have 3 plus or minus the square root of negative 75, all of that over 6. Notice, now we have a negative under the radical. So if you're discriminant, what that means is that this kind of graph that never crosses or touches the x-axis has a discriminant that's going to be negative. So what's under your square root symbol is negative. And so that means, that's always going to mean there are no real solutions. You're going to have I in your answer. So if you see that, if you do the quadratic first and you come up with a negative, you know it. If you do your graph first and it never touches or crosses the x-axis, you know it, that you're going to have that kind of solution. All right, so let's look at simplifying under that radical. X equals 3 plus or minus. We want to take the square root of 75 is negative 1 times 3 times 25. We can take the square root of 25, and we know that the square root of negative 1 is I. So that leaves us with x equals 3 plus or minus. The square root of 25 is 5. Square root of negative 1 is I. What we can't do anything with under that radical is that square root of 3, so it stays there. And all of that is over 6. Now I can reduce 3 6, but I cannot reduce 5 6. So since I can't reduce both of them, we tend to just leave it like this as a solution. So that's the answer to that quadratic equation. And so our solution over here, you're going to write, and I'm not going to write it up here. I just have it in the box underneath. I didn't leave myself enough room. All right, so we're going to go now to number 3. This one's already in the form I need it to be. Let's check the discriminant. Let's go ahead and just do a little check on the discriminant to see what we get. Okay, so again, it's b squared So that's going to be b squared is 100, 10 squared, minus 4 times negative 3 times negative 5. So that's 100. Negative 4 times the negative 5 is positive 20 times negative 3 is negative 60. So we're going to take the square root of 40. So that's a positive square root, so it's going to have two roots. If the discriminant is 0, it's a double root. It's going to have one root. It's negative, so we know it's going to open down. If we put this in the calculator, we're going to end up looking something like this. So enter y equals all of that into the calculator, not the 3, sorry. Shouldn't have put that in, shouldn't have included that. Start there. There we go. All right, then you find your zeros. So then you're going to find your zeros using the calculator. And they're decimal numbers. They're not nice even numbers. And so they are 0.613 and 2.721. Round them to 3 decimal places. And that's what you should come out with. And I'm not showing you how to do it because you should have learned how to do that in 7-1. All right, now in 4, we're finding a maximum. That means that this should have a peak value. It should open down. To have a maximum, it should open down. And so you need to check and make sure that it's going to open down. And you look here and see this negative right there, and so you know that it does. So we have everything, y equals this. You just enter that whole equation. Enter all of this into your calculator. Sketch your graph. And this one does not cross the x-axis. But we can get an answer to this because we're not looking for the zeros. We're looking for the vertex. That's your maximum point. And that's what we're looking for, is that max. So this is a coordinate. This one has an xy value. And so when we put the answer here, we're going to put it as a coordinate, and it's 0.75, negative 2.875. Now you should be able to get those numbers in your calculator, so if you're not getting them, you need to be sure. And I want to tell you it's a point, so we're going to use our parentheses to designate that it's a point. This is not roots. This is a maximum. Okay. Now for the next problem. This time we're looking for x-intercepts. Well, x-intercepts are also roots. X-intercepts are also called roots. They're called solutions. Answers. The answer, what's going to solve that equation. All those kind of are used interchangeably. In a quadratic, when you put it in the calculator, that's the solution, is where it crosses the x-axis. Okay, so we've already got y equals, because f of x is the same thing as y. So you enter this in your calculator, the 2x squared plus 5x minus 7. It opens up because 2x is positive, 2x squared. And so you find that it's something like this. Again, sketch it in based on what you see in the calculator. So you're going to find the zeros. That's what you're going to find, the zeros. Root solutions, answers, zeros, all the same thing. So when it says find the x-intercept, you're finding the zeros. So this is what is on the menu. When you find your zeros, they come out to be negative 3.5, and 1. And again, this is 2 different points. This is not 1 point, so don't put this in parentheses. If you want to write it as a point, write 3.50 and 10. Okay, so that's 7-3.